Okay, so hello everyone. I'm Gilles Philippart. I'm a software developer at Société Générale.
Hi everyone, and I'm Namba. I'm a solution architect at Docker. And today we're going to be talking about, let's see here, configuration management. How many people here know about Docker? Yeah? All right. How many people use Docker in their day-to-day lives? Okay, good. Well, today we're going to be talking about configuration management. You guys have to deal with configuration management too? Environment variables, that kind of stuff, yeah? How many of you guys love that? Yeah. Well, it's one of those things where you have to, you know, nobody talks about it, but everybody has to do it, and strategies for how to do it, you know, it's not an exciting topic, but once you figure out how to do it correctly, it's really satisfying and fulfilling. So that's what we want to share with you guys here today. We've worked together for the last year on some Docker projects at his company, so we're going to hopefully give you guys some good strategies and tips today how to organize yourself. Okay, so 3 topics we're going to go over today is what goes in an image. A lot of questions around that. What do I put in? What do I keep out? Do I mount volumes? Do I do environment variables? What do I do? The second topic is, once you've figured all that out, how do I then manage all of those configurations? We're going to give you some strategies around that. And then finally, once I have those configurations, where do then I store them? Do I put them in version control? Do I put them in some sort of registry? How do I do all of that? All of these topics as well are in a reference architecture that you can find on the Docker website. It's called Development Pipeline Best Practices Using Docker EE. Now, how we're going to do this presentation is, what I'll do is I'll present the general topic and different strategies that you guys can adopt. And then Gilles, he'll go through what they actually implemented, which strategy they chose at their company and on their project. Okay? So what I do is I go into companies and I help them Dockerize their applications. And usually we go in there, have a meeting, they have a simple application, and in about 15 to 20 minutes we can get a Docker file written, run it in a container on somebody's laptop, and they're super happy. They're like, wow, this is amazing, it just works. Just like this baby, they're pretty happy about that. And what we're going to see is, once you have to then push that into, you know, a real production environment across and deploy it across several environments, you know, development, integration, UAT, staging, pre-prod, prod, whatever, it can get a little bit more complicated than that. And some of the decisions that you guys will make along the way can make that journey a little easier or harder. So that's what we want to take you through that today.
So Lee is right. Actually, we just had a meeting, and we decided which service we would migrate to Docker. And at the end of the hour, we had it up and running. So, and this is what we came up with after like 20 minutes of work. And most of it actually was spent building the Java 8 image at the top. And but now we are in production, and I can tell you that it's quite a bit different than this. Now, before diving into our architecture, just let me tell you a bit more about our business. So I work for Société Générale. It's a bank, French bank, and so we've built the financing platform to power the business of the global finance division. And this division, it provides solution to companies to raise capital, to finance their project, to hedge their key transactions against risk. And we also do business in a lot of sectors, right? Did you know, for example, we helped finance the renovation of the Miami Stadium for the Super Bowl back in 2007? So yeah, that was us. We also finance infrastructure projects like bridges and universities. And so yeah, so let's see now how we architected the platform. So it's built around a microservice architecture because it's cool. Okay, not only cool, but it also provides a lot of benefits. So these microservices, they are business oriented. They have basically there is one per domain, per business domain, and if you are familiar with that, it's called domain-driven design, or DDD for short. Since they have completely different time life cycle, you can update any of these guys whenever you want. So it provides quite a lot of agility. And another benefit is that these services, they can be written in any language, and because they just have to speak the language of the system, and this language, it's just REST and messages. So for example, we have built most of them in Java, but now a few of these are in Kotlin, and hopefully, maybe in the future, some will be written in Clojure, which I heard very much. These services, they are stateless, and they are Spring Boot application today. And actually, we don't have only these that you can see here, but we have more than 30 of these. So today we are in a VM world. We deploy in VMs. And we want to put all these services in Docker. And we want the migration to be nice and smooth, so we don't want to do big bang. And also, we don't want to refactor the application to, adapt and do something Docker specific and keep the VM stuff in another branch or something like that. So we chose to have a lift and shift approach. So we will try to make no changes in the code and basically no changes in the configuration, and we want refactoring to happen later when we are in Docker, because everything will be so much easier. So we'll need to do canary deployments. So that means that we have both Docker and VM running side by side in production, and we'll progressively fly traffic from VM to Docker instances for some users, for example. And we also have another challenge, that is we have many environments. So we have dev, we have integration, homologation, UAT, production, of course, and support also for debugging purposes. And so we had to find a way to keep track also of which instances, which copy of the code were deployed into some environment.
Okay, the first topic we're going to go through, now that we know their context a little better, is what should go into an image. What should go in, what should stay out. So the question and the answer is, pretty classic consultant answer is, it depends. So I want to give you two basic types of images. There's one type of image called the builder image, and this could be building your application, compiling it, packaging it, assembling it. It could also be an image that actually builds your Docker image as well. Now, in these kinds of images, you can throw everything in there. You don't care about size. It can get into the gigs. You throw your tooling in there. You throw your scripts. Any type of patching that you need to do. I wouldn't worry too much about if it's ugly, just because all it needs to do is build something for you. This is a tool that usually is going to run just once as a single instance. If you have it in any type of CI/CD pipeline, then it'll run continuously. But it's not something that's necessarily going to be going into production. And so just like this, console, you can throw, a bunch of stuff in there. Now the second type of image, this is your image that will actually be run in production. And these are going to be more long-lived. They'll be out there running. You want to be able to scale them sometimes, so have multiple instances of them running for redundancy or for performance reasons. And in this case, you probably want to just stick to one component per image. So that could be a web application server, could be a database engine, but just have one component per image. And now with the multi-stage builds, what you can do is actually combine these two images into one Docker file, where you have one part of the Docker file doing your build app or your build image, and then once you've created the artifacts for that the build, then you can put that into your run image. Okay. Now let's double click on these run images types. So there's still some questions, what should actually go into these run images? I'm going to give you 3 different types of images that we categorize. So the first one, you probably all heard of this. This is a base image. What do we put in the base image? It's usually your OS and your middleware. So some type of application server or engine. And the things that you externalize, that's going to be the actual application itself. So in the Java world, let's say that's a WAR file or JAR file or some type of node or PHPs. And then the configuration stays on the outside as well, where you mount a volume. So these are what we'd call a base image. And the other side is what we would call an environment image. Now, why do we call it an environment image? It's because it's specific to, let's say, UAT, or it's specific to pre-prod. And at this point, you bake everything into the image. All of the configuration, the actual application, everything. And one of the advantages of doing this is it's extremely portable. In other words, you can take the same image and you can run it in your production servers, you can run it on your laptop, you can run it in the cloud, anywhere you want, because everything is baked in, then it's completely portable. And also, since everything is baked in, everything within there is traceable. Now, in between, obviously, there's a compromise, which is a release image. Now, this is where you put the actual application or the version of the application that you want to run into the image, and then the only things that you inject inside are your environment variables. And we call this type of image environment agnostic. And so this gives you a nice combination of, okay, it's still flexible because we can inject in things for just a particular environment, but yet it has enough traceability and portableness that you can then apply it to different environments. So let's take a look now and see what they did with the financing platform, which strategy they chose.
So this was our first try. So we had an image per environment, and we tried to put everything in that base image, in the Linux distribution, Maven, JDK, Node.js, you name it. So, and this kind of Dockerfile, it's quite difficult to maintain because if you're familiar with Bob Martin's solid principle, and the first letter, S, it stands for single responsibility principle. And this Dockerfile, it's a clear violation of this principle because it tries to do too much. And besides, it's not very reusable. If you build this and you want maybe some of the team to reuse part of it, they have to take it all. So we tried to put also the environment configuration files inside the image for traceability, like Lee said, but this was a bad idea because now your image is tied to a particular environment. Okay, second try, we pulled out the environment configuration out, and now it's better because it's environment agnostic, but you still don't get much reuse across teams. So finally, we settled on this setup. So the GTS on the far left, it's our ops team. And they focus on low-level details like the operating system, the security patches, network settings. And in the dash rectangle, you have the build-only stuff. It's only used at build time. It's used for building the jars, for packaging the JS applications. And it's under the responsibility of our transversal architecture team. And they also built a GRE, Java Runtime Image, to run in production. And my team, it's on the far right. And so we built the release images that you can see on the right, and also the Spring Boot microservice, which is an abstract Dockerfile that we will dive into it a bit later on.
All right, so now we know we have a basic strategy for what should go into an image. But we still have some questions to where should I put my configuration. I'll give you an example of that. In Docker, you can set a variable, right? So let's take an example. Let's do a simple one. Okay, so the first one that we usually all learn is in the Docker file, environment variable, foo equals bar. It's pretty simple. It's in the image. That I can live with. But now let's say I want to pull it out. I don't want it baked in the image. So now I'm going to do it actually in the command line. So I can do Docker service create, pass in an environment variable. That's great. But now let's say I'm getting sick of typing that in every single time. So we'll put that in a compose file or in a stack file. I'm sure you guys all have done that. And we put that as, slightly different syntax, environment, foo equals bar. That's great. But imagine now, like in their case, they had about 200, because this was a legacy application. They had about 200 variables that they had to set. So in a Docker compose file, that gets a little unwieldy. So we said, okay, we can actually split that out. Let's put that in an actual environment file. So foo.env. But there were some, as well, variables that they didn't know beforehand, and they were stored in an external configuration. So if that's your case, what else can you do? Well, you can actually use an entry point script. And you can call out, let's say with curl, or you can do any type of calls outside. You call out to that external service and then actually set foo equals bar right in your entry point. So that's another way of doing it. And finally, sometimes your configuration is secret, right? So yet another way of doing it. You can use Docker secrets to store these variables. So how do you choose which one of these strategies to take when you want to just set a simple variable like foo equals bar? And so my advice to you guys is think about the life cycle of these variables, okay? What do I mean by that? Just try to think about buckets. So on the first type of variables, these are things that are long-lived. So stuff that will change, maybe yearly. These could be more like enterprise-type tools or policies or libraries that you want to include in a base image. These could also be things across, let's say, an application program where you're gonna actually have not only your enterprise tools, but just for your program, its tools. And these are things that everybody across your program is going to use. So you can put all of those types of things directly into your Docker files. They'll get built into your images, and they're not going to change that often, so you don't have to update them. Now on the bottom part, these are things that will change more often. So what are these? These are things like your environment variables, which environment you're deploying to. As we'll see a little bit later, they had many different things to configure. Are they changing weekly? Are they changing daily? Are they changing per environment, per release of your application? Those are things you can put in directly into your environment configuration within your Docker Compose or your even on your command line. And then at deploy time, what you can do there is you can then put things like secrets. You can put it in your entry point script. You can even mount it as a volume. So these are things that really, at deploy time, I want to inject in. And then finally, there's actually runtime things that you might want to change. So this is your container that's actually running. And then what you want to do is, while it's running, maybe change some things. So that could be service discovery. That could even be debugging or profiling or changing your logging configuration. So think about things in terms of life cycles, and that'll help you structure out where to put different configurations. So let's see what they did here. Okay, so let me show you some of the Docker files we created. So this one is from our ops team, GTS. So they get to decide which base Linux distribution will be used. So in this case, this is Red Hat Enterprise Linux 7. And they also put some configuration for the YAM repositories, which will decide which packages can be installed in our own Docker files. Obviously, not all of them are authorized. And also which certificate authorities can be trusted. And this kind of stuff, we don't expect this to change very much over the course of the year. Next one, the Java runtime environment image. So it's maintained by the architecture team, and they choose which Java 8 update is safe to use in production, because they know better. They run security tests. They check the compatibility with the underlying OS, and they also check which bugs have been included in the latest releases, updates. And they also install a stronger encryption policy than the one which is bundled by default with the JDK, which is US specific. And this is our microservice base image, the abstract one. And we wrote it. We choose which user will be used, which group they will belong to, and which ports also get to be exposed. And please note the entry point shell script at the end, because I'll get back to it in a few slides. And finally, the release images. The release images are the ones that were on the far right on the previous big slide with all the images. And actually, they don't do anything in particular, because, well, all these microservices are just look alike for now. So these images, they are built by our CI/CD pipeline automatically whenever the source code changes. So they get published to the DTR, which is the Docker Trusted Registry. This is an excerpt of our Docker Compose. So now we call it Docker Stack instead, because Docker introduced the stack concept, which is a bit more high level. And
you can see how we specify the name of the environment that we want to run this service in. We configure also some cluster node for collecting metrics. And there's also a credential file, which actually is a Docker secret, and we will source it once we are inside our entry point. So let's have a look at the entry point that I talked about earlier. So first, we source the credentials file that was in the previous slide, and so we can use everything which was inside for the rest of the script. As I said, we use VMs today, and we want to migrate to Docker. So for the VM world, we use a deployment tool. So I don't know if some of you use that kind of tool also, but this tool is also responsible for configuration management. So it's called the CMDB. And this tool, it requires to be configured in a certain way, and the data must be in a certain shape, and the application, they also have to use some placeholder format so that the CMDB, the deployment tool, can replace the placeholder when you deploy the services onto the target machines. So we have this, because we want full traceability, we don't just put stuff in the CMDB and hoping that the CMDB will keep track of everything automatically, branches and so on. Usually it's not made for that. So we have a Git repository where we hold all that configuration data, and we just upload this data to the CMDB whenever the Git repository changes. So on commit time, there is a hook, and we launch a Jenkins job to populate the CMDB, right? This format, actually, it's a Yara format. I don't know if you are familiar. It's a Ruby gem, which is used by Puppet, and we use Puppet to populate the CMDB. So now in the Docker world, actually, we don't need this deployment tool anymore, right? But since we wanted to have both running side by side in production, we had to find a way to continue feeding the CMDB and keep it happy, and having some way to pull this configuration and feed it to the Docker to the Docker containers, right? So, and this is exactly what this entry point does when we say convert CMDB YAML to properties. Actually, it's just a script behind that, and it just pulls the configuration out of the Git repository, converts that into different properties file, and it feed that into the Spring Boot application, or we can even maybe subst that into our shell script if you want. And it works just very, very nicely. So, yeah.
All right, that's a lot of work, right? From our first 15-minute Docker file as a baby, wow, it works, to now it's like, whoa, we had to break this up into all of these things. We got to really think about parallel runs. And you know, it took some time to get all of this going properly, right? So now what we've seen is they've broken up all of their configuration into, do I put it in Docker files, in images? Do I put it in environment? Do I put it as secrets? Do I do it at entry point, at deploy time? You know, where do I put it? So they figured all of that stuff out, right? But there's still some questions, which are, I've done all that. Now, how do I put all of this into some sort of version control or configuration management? And so let's look at that now. And the way we think about it is, it's just like coding. So, as Gilles mentioned before, they had a CMDB, and in this view of the world, we're looking at configuration as data, right? I'm going to take all of my configuration, throw it in a big database, it'll be running, and then when I need it, I'll go look for stuff, and I'll query the database, and it will give me all of my information. And what usually happens around that is these are big products, they're complicated to install, and usually only a few people, mainly the ops teams, sometimes the CI/CD teams get involved with that. The developers, sometimes they touch that, sometimes they don't. So it's a different tool than developers use. Now with Docker, the way in which we view the world is configuration as code. So we can make this, this vision actually come true. The reason why that is because all of our configuration is simple text files. They're Docker files, they're compose files, they're stack files, they're environment files. So you guys can treat this just like how you would treat code. And one of the other advantages to that is once it's like code, then the ops guys use the same tools as the dev guys. So let's say in this case Git, they're both just pushing things into Git. And all of a sudden they're talking the same language. And that really helps them to break down that barrier between dev and ops and really get them speaking together. So this is just another advantage of thinking about things as configuration as code. So now once we've said, okay, all this configuration is just like code, we still need to organize it. And what I'll give you here is, as far as strategies, is still think about the life cycles of all of these different configurations. What do I mean by that? Let's take your image files. So everything you need to build an image, that's most likely going to have the same life cycle as your application. So I'm coming out with a new version of my app. Got some new code, going to compile it, create a new version. Oh, I added in a new environment variable. That should go into my Docker file. That might go into an environment variable somewhere. I should probably commit that and put it right next to my code. So I can have one repository, which is more about the build time. And I can put that right next to my source code. Now what I would recommend is then putting everything that has to do with actual running of these images, anything that you're going to inject at runtime, which is environment specific, put all of that into a separate repository. Why? Because they live a different life cycle. One is building images, the other one is I'm going to run something. And I might inject different things when I run it than when I build it, where I want to kind of keep everything the same. And one other pro tip that I'll give you guys is I worked on a project where we put all of our different environments, so we had I think 10 or 11 environments, and we put all of that configuration into one big master branch. And we separated out each environment per folder. So we had dev, all of our testing, even performance testing, etc. And then we were introduced new versions, because new versions of our application were coming, every 2 weeks. And so we'd say, okay, we put it in the new version up in here, add a new variable, deploy that to this environment. But then we're a couple versions back in a different environment, and trying to port different environment variables into different versions on different environments in this one gigantic master branch, it just became a nightmare. And so we tried several configurations, and finally what we figured out the best way to do is, hey, just put each environment in its own branch. And the advantages of that are, what it allows you to do is, you have in one branch, let's say it's some type of pre-prod, you can then start tagging versions. And I know every single version that's been deployed in my pre-prod. And if I want a different version on a testing platform, then I just have a completely different configuration for testing, and I can tag and version all of that. Now you might be saying, okay, that might get hard to manage as well, right? Because you have all of these branches. How do I port one change throughout all of the different branches? Well, that's where the tool comes in handy, and which is why we recommend putting it in some type of real version control, like a Git. And you can use the tool then to do all of your merging or your cherry picking into different branches, and it just makes your lives a lot easier. So let's see if they actually took that advice or not.
So as I hinted earlier, we tried to bake the environment configuration into the image. So at first we just clone the repo into the build directory, like on Jenkins, before building the image, and just use the copy directive. So as a benefit, you get full traceability because everything is in the image. But now you just have to make sure you have to keep track of which image tag has been deployed into each environment, especially into production. But there are downsides. You must copy all configuration to be environment agnostic, and you have to rebuild all images whenever your configuration changes, and it's not very build binary only once, which is a fundamental concept in continuous delivery. So, in my opinion, the best way to cope with environment configuration it's via the entry point, and in using this technique, the images they are environment agnostic. So you don't need to rebuild the image when the configuration changes. You just restart the container, and there you go. New configuration is here. As a downside, you need Git, but and you can lose out-of-the-box traceability unless you log somewhere, maybe via some environment variable, which configuration commit was used when you deployed the microservice to container. And yeah, so a few ideas of where we are going. So we listened very carefully to Lee, and as he said, we used for the big configuration Git repository, we used the master branch approach, and it was a total mess, as he said, because when you try to change something, refactor some parts of the application, etc., you can have the previous version working with the newly refactored configuration stuff. So it's very awkward. So in the end, we just made some branches, and we could not avoid this because, as he said, sometimes these environments, they have different life cycles. Maybe you have some training environment, and it will stay up and running like for 3 weeks because you are just training your users, you just can pushing new versions onto it. So we chose, lately we chose the run repository approach. So we separated the environment into environment configuration into their own repository, and this we did that for each domain. So when we want to change the environment configuration for, I don't know, for integration, we just check out the NDA run repository, and we check out the integration branch, make some modification, commit, push, and the CI/CD just redeploy everything and just take out, shut down the NDA integration stack, and just restart it with the correct configuration. So once you have the tools, as Lee said, it's very easy. You don't have to do anything. Just don't do it by hand for like 30 microservices because you will die. And yeah, one last thing is one particular interest that we have is to do blue-green deployment, and so we are still investigating that, and hopefully there is something which is coming in the next version of Docker to handle that more out of the box, in a out of the box way. All right,
Okay, so in conclusion here, we looked at the 3 different topics, and they chose to use release images as the nice compromise between flexibility and traceability or portability. They went through and they did the exercise of thinking about configuration buckets and life cycles, where to put different things. Put it in images, put it in environment variables, or as secrets, or in an entry point. And then finally, to store all of that, they separated out all of their build into one build repository, and then all of their configuration at runtime into a separate repository, once again because they live separate life cycles. So we hope that just some of these tips right here and strategies will help you guys so that you'll be like this baby, you'll stay nice and happy, and you'll enjoy your journey.
Thank you.
Thank you. You guys have any questions?
Yeah.
Oh.
How do you handle secrets files and version control them?
So the question is, how do you handle secrets? Because you just can't put secrets in plain text into version control. Actually, we did that, but we did not put that in plain text. We encrypted these with a gem which is called eYAML, like encrypted YAML, and where you can encrypt the values of some YARA key, some YAML key. So this is what we did for until today, actually, and these secrets, they were put in plain text, but inside the container. So the container, we pushed the decoding key, the public and private keys in Docker secret, and the script just pull out the key and just run the YARA mechanism that you saw, convert YAML, blah, blah, blah. And it unencrypted the keys and spit out the property files, and they have the secrets in plain text, but you can't access a container from the outside unless you are authorized. So it's secure enough for us. Now we are considering maybe migrating this stuff to Vault, but the main problem remains that do you want to put that in Vault and just say everything will be stored in Vault and nobody can maybe read back the secrets, and maybe you can't even decode it. Actually, for example, in Docker, you can't read a secret, if I remember correctly. We have not completely decided what we want to do with secrets, and it's an ongoing topic also in the Docker community, because there are a lot of bad practices and people are uncovering new ways to do it, but there is no definite answer, so we are still investigating.
I'll follow up on that. Is if you're staying just within the Docker world, so you're using Docker secrets, the best practice today is to just version those secrets. So you'll write in a version, my secret, Docker secret create, and the name you'll give it a version. So that could be a date, it could be a tag, it could be anything, version 1. And then if you want to rotate those secrets, then you create a new secret, version 2, and then you adjust. And that way what it does is your secrets then become traceable as well. In other words, it's not just my MySQL password and it's the same variable every single time. You can know exactly which version of that password based on a date or based on a SHA or any type of sequence that you want to use. Yes.
Okay, the question is, we use console, and how do we use it? Actually, we don't use it for configuration management right now, but we plan to. And the question remains, do ops or dev use console directly and just curl some configuration into it, and that's it. But my opinion is that we should, for configuration management especially, when it's not secret, you should have full traceability. So Git is, in my opinion, it's the best place to put these, because now you can review maybe in a pull request somebody who is trying to do something, and maybe you want to say, oh, no, don't do this because there is some better way, or no, you're not allowed to do this. We have like 60 developers, and some of them are in India, and sometimes there is a wall of confusion between teams because we don't work very closely, and they don't know what we are trying to achieve because of the distance and the culture, whatever you want. And sometimes they did in the CMDBs, they did modifications, and we were not aware of. And then, like 2 weeks later, it's like, oh, who did this? And we didn't know that they had changed something in some environment which worked for their environment, but not for the other one, because they were just responsible for this environment, and they felt that it was not their job to update all the environments and that kind of stuff. And it went like crazy, and we just spent days to debug problems. So let's put everything in Git, and let's just use commits and for triggering update in another system, so for example console. So we use console only for service discovery today. So we register our services in console, and so other services can look up services via console. And also we use some of the key value store in console to store some specifics about the service, like the contract that they provide, for example.
There is a debate. So we would have these debates between the dev and the ops teams, where to store, and console comes up all the time. So some of the advantages of using, or I would say the main the main thing that comes up is everybody says, yeah, but our Git, what if Git goes down, right? And whereas console, you can make it high availability and disaster recovery and all of that. So there's this sort of debate that's going on. Should you introduce another system there? And as Gilles was saying, you should probably only have one golden source. So use Git as your golden source. That way you trace everything. Because what happens if you go to console, I would think of it more as a cache of your golden source. What happens if you go to console, then let's say you need to start rolling back things. Then all of a sudden you're like, oh, well, let's start versioning things in console. And then as he said, it's like, well, who changed what in console? Oh, okay, let's start assigning, role-based access control into console. And then you start doing traceability and diffing and everything. You end up redoing Git in console, right? So if that's the case, what's the better thing to do is to just make a Git, and if you have to, create a enterprise Git or a highly available disaster recovery Git just for configuration management for your runtime. But as we see today, I mean, if developer platforms or Git goes down, your company loses so much money anyways, that the big trend right now is that it's just as valuable as production, right? It has to be up all the time.
I just want to add that when we say Git, actually we say GitHub. We mean GitHub because we have a GitHub Enterprise on premise.
Yeah. So the question is there's build apps and there's run apps, and the build apps are usually bigger, and the run apps, you optimize them. The question is what if in your CI/CD pipeline you have a lot of build apps?
And we do.
Yeah, and they actually do. So this is just two ends of the spectrum. Obviously, you can then have something in the middle, and you can actually start to optimize your build apps as well. It all depends on what your frequency is of your CI/CD pipeline. Do you want to add anything to that?
Yeah. We actually are running into some problems about the build app. Not so much because the build app are too big. It's rather that, for example, we are in Java, right? So we use Maven. So when we say Maven, we're a company, we use Nexus or Actifactory or whatever, and we have trouble with, for example, the local repo, which will hold all the dependencies. It tends to be very, very large, and we have run into problems with that because the host can be very. There is not too much space, and it can be a bit cumbersome to have all these build images all over the place. Maybe some team will have that part of these libraries, another team will have these libraries, but you don't want to share these, right? Because you don't want side effects during builds. So each one should have his own volume, this volume, and so on and so on. So it's difficult to decide which strategy. Do we have a shared volume or a volume mounted? Do we, in some base build image, do we just pull every dependencies that we can and have that as a layer in the Docker image? It's difficult to say. And we also had some problem because some builds were running on nodes in the Docker swarm where they were not supposed to. So we are still finding some solutions to that, and we have some actually.
Yep. Did that answer your question?
Yeah, so I have to try out.
But if the problem is the size of the build image, you can apply the same techniques than for the run app. Obviously, you can. I don't know if you don't need some part of. You can obviously there are some techniques you can remove, avoid to have big zip files across layers. Just remove them whenever you can, and so on and so on.
One command that's very helpful for optimizing images is you do a Docker history, and then you give the name of the image, and it'll print out in reverse order all of the layers basically, and all of the commands that go into it, and also the size that it adds. And very quickly you can see, I did like a copy and then an unzip, whereas I could have just done that in one thing, and I can minimize the size of my image. Okay. Thank you guys. Don't forget to vote.